Welcome, Calculus 1 students. We're going to continue with some product rule, quotient rule, and chain rule, and work through three related problems. I thought I'd remind everyone of a fact that you might want to make a memory fact. We use the derivative of square root of x quite a bit, so I just wanted to remind everyone that if we have an expression that we need to differentiate that contains square root of x, then the derivative of square root of x is 1 over twice square root of x. Yeah, you might remember that if you think of square root of x as x to the power of 1/2, then by the power rule we end up with 1/2 times x raised to the negative 1/2, which would then drop a half power of x to the denominator. And we get to that memory fact. And I've designed this little review video where you might want to stop the video pretty quickly, jot these three functions down. Here we have the square root of 3x. G is a product, square root of x times tangent of 3x. And then r of x is the square root of this quotient, 2x minus 3 over 4 minus 5x. So you might want to pause right here. Okay. Now if you've paused, you might be ready to pause again, or you might want to just remember here about at minute 1:45, or right about 2 minutes, we're going to show the solutions. So I'll move this page. And if f of x is square root of 3x, then later on in this video we'll verify that the derivative of the square root of 3x is just square root of 3 times the reciprocal of twice square root of x. And we'll verify to get the derivative of g we had to use the product rule, and we'll get this blue answer right here. I've put a little green asterisk because there is a way to simplify that answer in blue with a common denominator. And then later you can verify that if r was the square root of that quotient, then r prime is negative 7/2 times this funny quotient, 1 over the square root of the top difference and a 3/2 power of 4 minus 5x. So I hope you can read that as a 1/2 power and a 3/2 power. So the answers in blue are fairly friendly and they are correct. Let's get to verifying that. Okay, so let's start back with function f. Okay, if f of x is square root of 3x, we can treat this one of two ways. Some of us might want to just think of this as the square root of 3 times the square root of x using a property of radicals. And then to find the derivative of f, we have the scalar quantity that's multiplying the expression square root of x. So we would keep the scalar, and we just need to take the derivative of the square root of x. So keeping the scalar and then multiplying by 1/2 x to the negative 1/2. Emphasize that that's negative. We can multiply the two fractions together, or at least these two scalars, and if that's a negative power of 1/2, that's the reciprocal of x to the 1/2, and we do arrive at the advertised answer, f prime equals square root of 3 all over 2 square root of x. Okay. Now let's compare that real quickly, and you may want to do this on your own, to using a different strategy. In strategy 1, I noticed I had a scalar square root 3. But in strategy 2, if I just think of this power, that radical square root, being applied to both the 3 and the x, then I can use the extended power rule, bring down the 1/2, leave the base alone, subtract 1 from the exponent, and then multiply by the derivative of the base, which gives me 1/2, gives me the product 3x to the negative 1/2, and then the derivative of 3x would just be 3. Okay, so later on you might want to compare what we simplify to with the answer to our third problem. So you may want to stop later and compare this to when we differentiate r. Okay, well, let's rewrite this. Let's compare this blue answer, which is 1/2 times the reciprocal of the square root of 3 times the reciprocal of the square root of x times 3/1. And the 3 over the square root of 3 will simplify. If we take these two factors, we get square root of 3/1. I have a 2 in the denominator, and then I have the reciprocal of square root of x. So these two answers are equivalent. There's just a little different way of looking at it. Okay, let's return then to the second example. We want to